This is part 2 of section R.6. We're working on our third synthetic division problem. Here we're to divide x cubed minus 4x squared minus 5 by x minus 3. Okay, x minus 3 is what we're dividing by, so what will we use for our divisor? 3. Good. 3 divided into 1x cubed minus 4x squared. Notice we don't have an x to the first term, but we can't just skip that. We have to have a placeholder. We have 0 x to the first, and then minus 5 is our constant. You have to have that placeholder to get the right answer. So once we start with an x cubed, we need every power of x down to the constant represented here. Don't let that trip you up. Always start and just say it out loud to yourself. 1x cubed minus 4x squared. 0x to the first minus 5. Okay, what's the first step? Yes, bring down the 1. Multiply, add, multiply, add, multiply, add until we're done. 3 times 1 is 3. Negative 4 plus 3 is negative 1. 3 times negative 1 is negative 3. 0 plus negative 3 is negative 3. Negative 3 times negative 3 is 3 times negative 3, is negative 9, and we add to get negative 14. There's our remainder. These are the coefficients of the quotient. So let's write our quotient. Remember, we've dropped one power, or you can check by saying constant, first degree, second degree. It was x cubed, so now we have 1x squared minus 1x minus 3. There's our quotient, and our remainder is negative 14. Okay, let's go over these theorems then. The remainder theorem says that if our remainder is 0, I use a uppercase, lowercase r, doesn't matter, but I'm just referring to our remainder. If our remainder is 0, then x minus c is a factor of f of x. Remember, we looked at that in our second example, and we talked about the fact that we had found a factor of that polynomial because we had a remainder of 0. The factor theorem says that if f of c is 0, then x minus c is a factor of x. So what is this saying? Let's see. We'll practice it here by using our example 1b to test this out. So we had found that the remainder was 0 and said that then x plus 3 must have been a factor. But let's see what this is saying. So in 1b, x minus c specifically was x plus 3. So c equals what? If it's minus, then it must be negative 3. Remember, that's what we divided by. So in other words, we are to find f of negative 3 for 2x to the 5th plus 5x to the 4th, etc., etc. So our original f of x would have been, let's see if I can write that here. So f of x would have been 2x to the 5th plus 5x to the 4th minus 2x cubed plus 2x squared minus 2x plus 3. So let's plug in negative 3. So we have 2 times negative 3 to the 5th power plus 5 times negative 3 to the 4th power minus 2 times negative 3 to the 3rd power plus 2 times negative 3 squared minus 2 times negative 3 plus 3. So if we simplify all of this, we should get 0 because we already know that the remainder was 0 in that problem. Okay, so if we say negative 3 to the 5th power, we get 2 times negative 243 plus 5 times negative 3 to the 4th will be a positive 81. Minus 2 times negative 3 cubed would be a negative 27. Negative 3 squared will be 9. Negative 2 times negative 3 is 6. and there's our constant. All right, so we get negative 486 here, plus 405, that's going to be plus 54, negative times a negative, plus 18, and we'll pull those together and get 9, 6 and 3, and this is negative 486 plus 486. These numbers all add up. That one's the negative. All of these are positive. In other words, we do get 0. So that's another way to determine whether or not you have found a factor of f of x.